Today we will look at another rule that will help us solve non-right angle triangles. It is called the cosine rule. Suppose we have a right angle triangle ABC as shown, and that we drop a perpendicular from B to the base AC, and let's call its length as H. Now if the base AC is called little b, then if this length is x, what remains here is a length of b minus x. If we apply Pythagoras on the left hand triangle, we have c squared, which is the hypotenuse, that's equal to x squared plus h squared. And if we make h squared the subject, we have c squared minus x squared. If now we turn our attention to the pink triangle and apply Pythagoras again, we have a squared equals h squared plus the base, which is b minus x whole squared. And if we expand that and we replace this h squared by c squared minus x squared, we have c squared minus x squared, which was our h squared, and the expansion of b minus x squared is b squared minus 2bx plus x squared. Luckily, we have a negative x squared and a positive x squared that cancel each other out, and we end up with a squared equal to b squared plus c squared minus 2bx. Now, a, b, and c are all sides of the triangle. But how can we find out what x is? What we can do is use this triangle to find the value of x. For x divided by c is simply cosine a, because this angle a is in a right angle triangle, and x is the length of the adjacent, c is the length of the hypotenuse, so x over c is cosine a, and by cross multiplication x equals c cosine a. So we take this and we substitute it for x here, and we end up with a squared equals b squared plus c squared minus 2bc cosine a. And that's the cosine rule. Now we have to master the cosine rule, because it comes in different forms. Our form was a squared equals b squared plus c squared minus 2bc cosine capital A, because that's what represents the angle. A reformulation of the cosine rule, which is not a change of the subject, can be based on a different analysis of the triangle and a different perpendicular that was dropped, and it may turn out to be b squared equals a squared plus c squared minus 2ac cosine b. Can you see the pattern? C squared would equal the other two sides squared, so a squared plus b squared. Then we have a minus 2, and the two sides that are represented here are a and b, and then we have cosine of the angle whose letter is the same as the side here, so cosine c. And if we have a triangle PQR, then similarly P squared is equal to R squared plus Q squared minus 2RQ, and then you have the cosine of capital P, and so on. The conditions to apply the cosine rule: you either need 3 known sides or 2 sides and an included angle. And the good news about the cosine rule is that there is no ambiguous case, and you only need to apply it once. Because if you apply it once, if you want to work further on the triangle and you want to work out other sides or other angles in the triangle, you can use the sine rule. Now let's say that we have this triangle, which is just a sketch, and that this side is 12, AC is 9, and BC is 6 units long, and that we want to find this angle. So we have three sides and we want to find a particular angle, which is B. So we need the formulation of the cosine rule that contains cosine B, and that would be B squared is equal to A squared plus C squared minus 2AC cosine B. Substituting, little b squared is the 9 squared, little a squared is 6 squared, and c squared is 12 squared, minus 2 times 6 times 12 cosine b. Rearranging gives us 9 squared minus 6 squared minus 12 squared equals 2 times 6 is 12 times 12 is 144, so that's negative 144 cosine b. Let's work those out. This is 9 squared minus 6 squared minus 12 squared, and this equals negative 99 equals negative 144 cosine b. So cosine b equals negative 99 over negative 144, and this allows us to evaluate the angle b as 46.6, say approximately 47 degrees. Now that you know that this is 47 degrees, and you can proceed to evaluate the angle C or the angle A, but then you don't need another application of the cosine rule. All you need to do is the sine rule, because 9 over sine 47 would equal 12 over sine C. And if you work that angle out, you can subtract the sum of the two known angles from 180 and you'll work out the value of A. Another example, let's say that we have PQR as a triangle and that this side is, let's say, 9 centimeters, this is 8 centimeters, and that this angle is 32 degrees. What is the length of this side? Now this side is little q. So what is the formulation that we need? We need q squared is equal to r squared plus p squared minus 2r p cosine capital Q. And substituting, q squared would equal 9 squared plus 8 squared minus 2 times 9 times 8 cosine 32. And this equals 81, that's 9 squared, plus 64, that's 8 squared, minus 2 times 9 times 8 cosine 32. And this is 22.88. Actually, we don't need to write this down because what we need is q. So in order to maintain accuracy, we can take the square root of the answer immediately. So the square root of the answer is equal to this value, so Q is equal to 4.78 centimeters. And that's the cosine rule.